All right, let's talk about SSH. It's one of those things that, kind of runs the entire internet from behind the scenes, but most people have never even heard of it. It's absolutely crucial. So what is it? Let's dive in.
So think about this for a second. How do you actually control a computer that's maybe thousands of miles away? How do you tell it what to do? And more importantly, how do you make sure that no one is eavesdropping on that conversation? Well, that's the exact problem we're going to talk about today. It's kind of hard to imagine now, but the early internet was basically the Wild West. Seriously, when you connected to another computer, everything you sent, your username, your password, every single command was just out there in the open in plain text. It was a total security nightmare. So yeah, this is where our story really kicks off. The internet had this huge fundamental problem right from the start. There was just no privacy. The early tools, they were built to work, not to be secure, and nobody was really thinking about a world where people might be snooping on the network. I mean, just look at how bad it was. Before SSH came along, you'd use something like Telnet, and your password would literally travel across the internet as readable text. Anyone who knew how to listen in could just grab it. Same with your commands, your data, all of it. Not good. And this wasn't just a theoretical problem. Back in 1995, a researcher in Finland named Tatu Yalonen actually saw a password sniffing attack happening on his university's network. He watched his people's credentials, which is getting stolen left and right. So he said, okay, I'm going to fix this. And he created the solution that really became the hero of our story. And here it is, SSH, which stands for Secure Shell. So what is it? Well, at its heart, it's a set of rules, a protocol, that uses really smart cryptography to let you talk to another computer safely, even when you're on a totally public network like the internet. And the name? It's perfect. It tells you exactly what it does. The secure part? Well, that means everything is encrypted, right? It's all scrambled up so no one else can read it. And the shell part? That's the command line, the terminal. It gives you direct access to control that other machine. Secure? Shell. Simple. So how in the world does it actually pull this off? It really can feel like magic, but it's not. It's just some really, really clever math and cryptography. So let's pop the hood and see how it works. This is probably the best way to think about it. Imagine the internet is this giant, chaotic public highway. SSH builds a private, armored, totally invisible tunnel right through the middle of it, just for you. Inside that tunnel, everything you say and do is completely safe from the outside world. And that tunnel gets built through something called the SSH handshake. It's kind of like making a secret phone call. First, your computer calls the server. The server answers and proves it's the right server. Then you both agree on a secret language, a specific type of encryption that only you two are going to speak. Then you prove who you are, and boom, the secure call begins. Okay, that last step, that is so important. Proving your identity. How does that server really know it's you talking to it? This is where SSH gets super smart with a concept called cryptographic keys. To really get this, we're going to switch analogies. Let's forget the phone call for a minute and talk about a secure mailbox. This idea really makes public and private keys, which are the heart of SSH security, make a whole lot of sense. So here's how it works. You have two keys that are mathematically linked. Your public key is like the mail slot on your mailbox. You can give it to anyone. They can use that slot to put an encrypted message inside for you. But, and this is the key part, only you have the private key, the actual physical key that can unlock the mailbox and read the message. You never, ever give your private key to anyone. And that system is what makes SSH so incredibly strong. I mean, you can still use a password with SSH, but that's like putting a cheap padlock on a bank vault. It's vulnerable to being guessed over and over. Using keys, though, that's like having a password that's billions of characters long. It's basically impossible to crack. It's why it's the gold standard for any real-world professional system. All right, so we've seen how it works, which is cool. But let's zoom out a bit. Why does any of this matter? Because this little protocol isn't just some niche tool. It is an absolute pillar of all modern technology. And if you're working in tech, or want to, this matters to you. Because understanding SSH isn't just optional, it's a requirement. If you're into cloud, DevOps, cybersecurity, heck, even software development, you're going to be using SSH, probably every single day. And here's a little bit of networking knowledge you just got to know. By default, SSH listens on port 22. You know how websites use port 80 for HTTP and 443 for HTTPS? Well, SSH has its own special door, port 22. That's a fundamental piece of the puzzle.
And don't for a second think that SSH is a one-trick pony. Oh no, it is a complete Swiss Army knife. Yeah, you can log into servers, but you can also use it to securely transfer files, to automate massive software deployments, and even to forward other network traffic through that secure tunnel we talked about. The versatility is just mind-blowing. So, at the end of the day, SSH is this silent hero, this protocol of trust that's constantly working in the background. It's what allows the entire cloud to exist, what allows us to manage this massively interconnected world in a secure way. It's that invisible, encrypted handshake happening millions of times a second that truly holds our digital world together. Makes you wonder, what other invisible tech are we all relying on every single day?